Asteroids. The majority of asteroids are found in the asteroid belt. Something like more than 70% of all known asteroids are found in the asteroid belt. And this is the region between the orbits of Mars and Jupiter. So on this picture here, it's represented as this swath of dots. So here we see where Mars is, here we see where Jupiter is. And so this belt of asteroids are found between these two planets. And the asteroids orbit around the sun just like the planets do. Now if you go to many science fiction movies, at some point you will see a spacecraft flying through asteroids. And so here we see from Star Wars, Han Solo flying through the asteroid field. However, that is misleading. If you actually went to the asteroid belt, odds are you would not see any asteroids. It's something like 0.00005% of the asteroid belt actually has asteroids in it. So you're pretty safe flying through the asteroid belt. The pictures we have up close of asteroids are because we intentionally steered a spacecraft to be close to an asteroid. And otherwise it would not have seen any asteroids at all. This is why we can send spacecraft to Jupiter and beyond, because we can point a spacecraft out to the outer planets. It's going to fly through the asteroid belt, but we know it's not going to run into any asteroids. When we classify asteroids, what we're going to look at is their composition. And here we're seeing some pretty typical looking asteroids. They have strange, irregular shapes, and that's because they're small. Asteroids typically are on the order of 10 to 11 miles across, not big enough to pull themselves into round shapes. So these typical kind of potato-like shapes is what you are going to see for most asteroids. The most common asteroid composition type is a C-type, where here C stands for carbon, but these also have silicates and metals as part of their composition. And here we see asteroid Matilda is an example of a C-type. Not only are these the most common, these are also the least changed as far as composition. They have not gone through any kind of melting or anything like that, so what you are seeing is kind of pristine examples of the early solar system, what our planets formed out of. You know, what was here in that disk when the first planetesimals and protoplanets formed. And so the C-types are going to give us these very unique materials before they have been changed. S-types, here S stands for silicate. So Ida is an example of an S-type. These are rocky materials. And the thought is that there was once a differentiated object that broke apart. So it had separated out the metals and the rocks, and then when it broke apart, probably by a collision, you then have materials that are going to be made from these different layers. So the S-type is going to be from the crust of such an object. So similarly, the M-types made of metal would be from the core of the broken apart differentiated object. So here we see Cleopatra, which is my all-time favorite asteroid because it looks like a dog bone. And it is an M-type. The metal primarily is going to be iron, just like in the cores of the terrestrial planets. So these are more or less solid iron asteroids. The rarest asteroid type are the basaltic asteroids. And here we see Vesta. Here's a Hubble image of Vesta. And then taking that image and doing a lot of computer enhancing, you get that second image. These have evidence of lava flows. So that implies geologic activity. Now, Vesta is one of the largest of the asteroids. It's in the top 3 largest asteroids. So it's kind of borderline, almost perfectly round. You can see in this elevation model, it's more or less a round object. So it does have enough self-gravity to pull itself into this roundish shape, and it could have enough self-gravity to actually melt its interior, and that would give it the molten material necessary for this geologic activity. Now, it could be very much like our moon. It was once geologically active and has since cooled and solidified. We don't know. We do have a spacecraft heading there, and soon we will know more about Vesta, which at this point is the only one we know for sure has this basaltic lava flow activity.